Okay, so these are the notes. So you can refer to page 419 until 425 on how to sketch the sinusoidal graph, which is the sine graph and the cosine graph. Okay, first of all, we introduce about the predict properties of sine and cosine. As we already know, the period for sine and cosine is 2 pi, which means that after 2 pi or after 360 degree, they will get the same location. Okay, for example, have sine 30 degree plus 360, then you will get back, or you will get the values of sine 30 degree. Okay, same thing for cos. If you have cos 45 degree plus 2 cycle, for example 2 times 360, which is 720, so it will give you cos 45 degree. This is from evaluating part. Previously we have already discussed about the predict properties. Now we want to look at its graph. So for the graph of sine, we start at 0, 0. You can look at this point 0, 0, and then we proceed with pi over 2. Okay, at pi over 2 here you will have, this is pi over 2. Here we have the amplitude is 1. So the coordinate will be pi over 2 and 1. This is 0, 0, the first key point. The second key point, pi over 2, 1 or 90 degree equals y coordinate is 1. And for the third key points, we have pi 0. Fourth key point, we have 3 pi over 2, which is 240 degree and negative 1. And lastly, we have 2 pi 0. So all of these, we name it as 5 key points. After this, we are going to sketch the graph using these key points. Okay, clear? And then we look at the key points coming from the graph of cosine. The graph of cosine, we start at 0, 1. This is 0, 1. So we have here, this is 0, 1. If you realize, this graph is actually we shift by 90 degree. Okay, 90 degree from the graph of sine. For graph of sine, previously we start here, right? This is the graph of sine. But when you shift 90 degree, because we have the co-function formula. If you read the notes provided by Madam Suraya, you will see what we call co-function formula. For co-function formula, it states that when we have sine 90 degree minus theta, it will give you cos theta. Okay, we'll explain from this right triangle. This is for the co-function formula, because we want to relate with the shifting to the left by 90 degree. So when we have theta equals to theta angle is here. Let's say this is your A, this is B, and this is C. If we want to find sine theta, you will get opposite over hypotenuse, which is B over A. And B over A also is actually, this is 90 degree minus theta. This angle 90 degree minus theta. Okay, this one. Okay, 90 degree minus theta. So B minus A, B over A also is cos 90 degree minus theta. So that's why we have here your sine theta. Sine theta is equals to cos 90 degree minus theta. or we have sine 90 degree minus theta equals to cos theta. For here, for cos theta, we have this is C over A. C over A is the cos theta, and it is also sine for 90 degree minus theta. This one cofunction formula. So if you look back at this part, this is actually minus 90 degree, theta minus 90 degree. So we have here, this is y equals to cos theta or y equals to cos t. Okay, the graph of cosine. Previously, we have the graph of sine. This one, this is a graph of sine. Y equals to sine t. So this is the relation between sine and cosine. It differs only 90 degree. Okay, and next we want to look at the domain of the trigonometric function. If you look at the graph, we already know that t can be all real numbers for sine and cosine. Okay, here your theta, it can be all real numbers. It is a continuous graph, it can be all real numbers. Okay, so now we want to look at the graph of tangent and secant. The domain is all real numbers other than pi over 2 plus n pi for any integer n. Or if you look at this graph, the graph of tangent, okay, this is the graph of tangent. Number one, this is the graph of tangent. Here, if you look at the vertical asymptotes, it is the odd multiples of pi over 2. It is odd multiples of pi over 2, or in other words, okay, your x can be all real numbers except pi over 2 plus n pi for any integer n. Integer, it can be positive integer and it can be negative integer. It means that odd multiples of pi over 2. It is the same. So every time we have 3 pi over 2, pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2, and so on, it will be the vertical asymptote. It means that the graph cannot cross the line, the vertical lines, okay? And then we have, this is the shape of the tangent, okay, the shape of the tangent. So from here, the period for the tangent is only pi. Pi, because we have here 3 pi over 2 minus pi over 2. So equals to 2 pi over 2, or we can say that the period is pi, ataupun 180 degree. Okay, every 180 degree you have the new graph. Okay, the shape is the same. This is for tangent. And for secant, okay, just now we have the domain. We want to look at the domain for tangent and secant. So we have the same thing, the vertical asymptote. It is the odd multiples of pi over 2. Okay. It is the odd multiples of pi over 2. Okay, you can write there VA. Of pi over 2. Okay. Okay, next for cosecant graph. Okay, cosecant graph you can see first. Okay, excuse me. Okay, sorry. Okay, we continue. For cosecant, if you look at the VA and also for cotangent, the VA is we have here multiples of, it is integer multiples of pi. It is integer multiple of pi. Other than that, we'll have graph. Okay, but for cotangent, it will reverse the graph from the tangent, and then for cosecant and secant, actually we have secant, it coming from the graph of cosine. Initially, we have the graph of cosine, it start from here. Ini graph of cosine. Okay, the green one is the graph of cosine, and so on. So the inverse is actually secant, because we know that secant x is 1 over cos. 1 over cos x. And for this one, it is inverse of sine graph. Okay, initially we have the sine graph is like this. So the inverse is dapatlah graph cosecant. Okay, so for this four graph, we have tangent, cotangent, cosecant, and also secant graph. Okay, we have to identify only. We don't have to sketch. No need to sketch, but you need to identify. Right? Okay, hopefully it is clear. And this is the predict for